I put it on the
Matt, I can give you a big hug. That's exactly what you need to say in that.
So this is our overall assembly.
What's the theme?
Unnaturally natural.
You ready to go? Let's figure it out. We do cryogenic hydrogen research, so liquid hydrogen research. And our goal was to design a liquid hydrogen fuel tank for the ScanEagle unmanned aerial vehicle built by Insitu.
Hydrogen is starting to take on a life of its own in the notion of an alternative energy source to become the substitute in a lot of applications.
Insitu is a wholly owned subsidiary of Boeing. It started in the Columbia Gorge, Hood River area. They produced, their first vehicle was ScanEagle, which is one of the most widely used unmanned aerial vehicles in the world. I think it's even approaching 1 million flight hours in service. It's seeing all kinds of applications from search and rescue to fire monitoring in our state.
They have demonstratable equipment in their labs, and so this notion of going from lab to design was really quite doable in all of our minds, yes.
Liquid hydrogen has 2.7 times more energy per weight than any of your other gasoline or kerosene fuels, okay? And it can be generated from water. So in distributed or difficult locations to get fuels, it can be really nice if you can make hydrogen on site. For instance, if you're using it to track a polar bear in the Arctic, the polar bear is actually really sensitive to a gasoline engine running overhead. So having hydrogen fuel allows you to go with solid-state drivetrain like a fuel cell. Part of our research was to 3D print the internal parts of a tank. So I've got just an example that we made with a 3D printer here on campus here. Basically, you can put we put liquid nitrogen in this to simulate the harsh, extremely cold environment of liquid hydrogen. And what happens is, as the cold liquid is in this center part, the vapor boils. It's continuously boiling because it's so cold. Those vapors go through these external flow passages around the outside here. And in that process of flowing, it ends up cooling or reducing the amount of heat that makes it to the liquid on the inside, which was a completely different approach to making a cryogenic hydrogen fuel tank than what we'd experienced in the past. And so we were able to prove the concept with liquid nitrogen, validate models. I mean, you can feel a little bit of cold, but on the outside, where that was liquid nitrogen temperatures and it would freeze your fingers to it, you can put your hand, the bottom's a little cold, but the side shouldn't really feel cold. And for something holding a cryogenic liquid like that, that's pretty incredible.
At this point in time, we're kind of in that, we have completed design, had what we would call our critical design review with them. We are now having hardware built to support our prototype testing.
The second class is a much more
from this side.
I want to work on rockets. Since I was young, I thought they were super cool. And when I saw an opportunity to get back into hydrogen research, which is heavy with rockets as rocket fuel, I thought that this would be a great opportunity.
On our JCATI project, we have one PhD student, we have a graduate student, and we had 2 other undergraduate students working on the project.
I started as an undergraduate on the project and worked on it for about 1.5 years, I want to say, on that project and some other related projects in the lab. And that really is what got me started as a graduate student here at WSU and deciding to stay on as a graduate student as opposed to going find something in the workplace and right away.
Just knowing that whatever I'm doing here is hopefully going to be directly used elsewhere. It's not just some abstract thing that I'm doing. I'm actually trying to make make something that will be used.
They can see the connection of what you're doing and how it's impacting and having a ripple effect into our state. It also helps give you real numbers for homework problems or anything else, any activities they're doing. It's not just a book exercise that was made up and they don't know where it came from. They actually realize that the numbers they're crunching were actually used to design a real system.
You guys totally embraced what I was saying on Friday.
He and his staff and his students are reaching for all kinds of new applications and all kinds of methods that can be changed, converted from the lab and science experiment to actual product applications.
This had to be a lot of work. Who did the lion's share of this?
It's amazing and absolutely essential, especially for a young faculty member like me that's trying to build a research lab. The little bit of funds from a JCATI project helps us get an experiment set up, and that experiment leads to future students and future funding. So back in the back, one of the students won a NASA graduate research fellowship, which is the top award NASA gives to graduate students in the country, because we had the equipment set up that he could produce from a JCATI grant that he could then use for his graduate research. We even started a startup company called Protium Innovations LLC as a result of this technology being one of the things we could produce.
So I see this as a start point, and then we're going to do some other, we're going to try some other chemistries over the next, I would hope over the next 2 to 5 years, to improve that energy storage capacity as well. So that's a big one there. This is not just a start and end point, but this is the beginning. So that's kind of the exciting part for us.
It's no longer an academic thing that we just do and talk about in papers. We're actually going out and trying to get a new business going that will hopefully end up building bigger and better things for our state.